Welcome students. Let us solve some more problems of Coulomb's law. Students, I am telling you, you have to pause the video and you have to write down the question, and after that you have to follow the same process to complete this numerical. Right. So question is, two electric charges Q and 2Q are at a distance A apart from each other in air. A third charge capital Q is to be placed along the same line in such a way that the net force acting at Q and also at 2Q is 0. Calculate the position of charge capital Q in terms of small q and A. A is what? A is the distance. So let us see the diagram. Two charges Q and 2Q separated by a distance A. Okay. And let us place a test charge capital Q somewhere in between. Okay. Remember students, if you want to make it equilibrium, all these three cases, what you have to do? If both are positive, this 2Q and Q, this capital Q should be negative. If both these charges are negative, the capital Q has to be positive. Let us take the distance from small q to capital Q is x. So what is the rest distance? A minus x. A minus x. So what is our question? A third charge capital Q is to be placed along the same line in such a way that the net force acting on Q and 2Q is 0. That means the both should be at equilibrium. How it is possible? If and only if the force acting at this Q by this is how much? This is a attraction case. Suppose this is plus, this is minus. Okay, there should be a attraction. Yes or no? And these two are same charge. So what will happen? There will be a repulsion. Right? So if these two forces are equal and opposite, then only your charge will stay at equilibrium. That means it will stay at its own position. Right? So we will find force due to 2Q is equal to force due to capital Q. On whom? On this. The force due to 2Q should be equal to the force due to Q. Then only it will be stay at equilibrium. So we will write down the formula. What is the force formula? Coulomb's law, 1 by 4 pi epsilon 0 Q into, who is applying force? 2Q, Q into 2Q divided by, what is the distance between Q and 2Q? Clearly from the picture, A square, R square, distance square, so that's why A square is equal to force due to Q. This Q, what is the distance? X. So 1 by 4 pi epsilon naught Q into Q divided by A minus X whole square. Right? This is equation number 1. Now let us find out the second equation. What is the second equation? We also want our 2Q has to be in equilibrium state. Then how it should be equilibrium? Same case. The force applied by Q to this 2Q is which side? This side. The force applied by Q to this 2Q is which side? This side, because these two are opposite. That's why attraction. These two are equal. That's why repulsion. Right? So these both forces should be equal and opposite so that your 2Q charge will remain at equilibrium. So let us write down the same thing. Force due to Q should be equal to force due to capital Q, right? So we will write down the formula. Force due to Q is how much distance? Is having a distance A. So 1 by 4 pi epsilon naught 2Q into Q divided by A square is equal to force due to Q. Q is having distance how much? A minus X. So we will write 1 by 4 pi epsilon naught 2Q into Q divided by A minus X whole square. Equation number 2. Now what we will do? Compare these both equations. 1 by 4 pi epsilon naught, in each case it will be cancelled. Yes, which one is same? These two are same. See the picture. It is clearly these two are same. So which we will equate? Only this and this. Right? So we will equate Q into Q by okay, there is one mistake. You just got this one. Okay, this is only x square. Why? Force due to capital Q is what? Capital Q is present here. So what is the distance? X. So Q into Q divided by what is the distance? X square. So as I told, these two are equal. Okay, 2Q into Q by A square, 2Q into Q by A square equal. So we will not take, only we will equate these two. So if we will equate from equation 1 and 2, Q into Q by X square is equal to 2Q into Q by A minus X square, right? Now you will get the answer. A minus X whole square is equal to 2x square. So A minus X equal to plus or minus root 2 into X. So X equal to plus or minus A by 1 plus root 2. This is my answer. So where should be placed? The capital Q charge should be placed at a distance x. So let us solve a new problem regarding electric field. So charges plus this Coulomb and this Coulomb are placed at 2 points capital A and B respectively, distant 5 cm from each other. Compute the electric field at point C, distance 3 cm from A and 4 cm from B. So this is the figure given in your book. Okay, in the question. A, B having a distance 5 cm, from point C 3 cm and B to C 4 cm, right? And now we have to solve. Okay, what we need to find? Compute the electric field at point C, okay. So how can we will calculate? Let us find out the magnitude of electric field E1. E1 is due to what? Due to this plus field. You can take A, and A here C is present, right? This is plus and minus, right? So let us take a test charge plus Q here. Your wish, whatever you can take. If you will take minus, you will get your own answer. Okay, if plus Q, so this is plus and this is plus, what will be the chance? Repulsion. So the electric field is like this. This is plus and this is minus. What is the case? Attraction, right? So let us name it. This is E1 and this is E2. So where will be the resultant field? Like this. So let us join this one. Okay, you know it. Which formula you will utilize? Parallelogram concept, right? So let us first find out E1. E1 is because of what? This charge. Okay, so what is the formula for electric field? Q by 4 pi epsilon naught r square, right? So E1 equal to 1 by 4 pi epsilon naught. Never forget, this is the value, 9 into 10 to the power 9 multiplied with q 1.2 into 10 to the power minus 8. This is 1.2 into 10 to the power minus 8. No need to take plus and minus sign. We are finding out the magnitude divided by r square. What is the distance? 3 centimeter. So we have to take in meter because we are dealing with the SI units. So we will take 3 into 10 to the power minus 2's whole square. So answer you will get 1.2 into 10 to the power minus 5. Sorry, 10 to the power 5 Newton per Coulomb. Okay, you have to check it by your own calculator. Now let us find out E2. E2 is because of what? This charge. So you will place again 1 by 4 pi epsilon naught, same formula, 9 into 10 to the power 9 into multiply 1.6 into 10 to the power minus 8 whole divided by, this is 1.6 into 10 to the power minus 8, that's why I placed and neglected the minus sign, divided by, what is the distance? 4. So 4 into 10 to the power minus 2's whole square. So we will get the answer 0.9 into 10 to the power 5 Newton per Coulomb. Right? So how can we will find out this E? By using the parallelogram method. So what is the method? The formula is root over of, this is E1 and E2. So what is the resultant? E1 square plus E2 square plus 2E1 E2 cos 90 degree. Right? So cos 90 degree is how much? 0. So what is the final answer? Root over of E1 square plus E2 square, that is 1.2 into 10 to the power 5 whole square plus this much square. You will get the answer 1.5 into 10 to the power 5 Newton per Coulomb. This is your answer. If you have doubt, you can place the value 1 by 4 pi epsilon naught is equal to, you place the value 4 pi into, what is the epsilon naught value? 8.85 into 10 to the power minus 12. You will get the answer 9 into 10 to the power 9. Okay, this value 9 into 10 to the power 9. So now we will find out the theta value, as it is asked, how much angle. So if this angle is theta, then what is tan theta? Tan theta is equal to what upon what? Tan theta is equal to E2 upon E1. Tan theta equal to E2 upon E1. And what upon what? You know it very well, right? Okay, so if you will place the value, you will get 0.75. So what is theta? Tan inverse of 0.75, that is 36.87 degree. Thank you.